Too loud now. We're good? We're good? This is a good level? Okay, sweet. Well, welcome to NervesConf. I was asked to speak, and we went through some ideas or topics, and ultimately came up with just to talk about some of the news, fun things with nerves, or things we've done. So the title, simply put, is What's New with Nerves? I have lots of links and QR codes in here. If you're into quickly snapping that, you can have your phones ready, get to the pages I'm talking about. Everything should be visible. And so yeah, when I'm talking to Frank about what to do, or some of the things we've done over the last year, and I was kind of feeling like it was fairly quiet compared to years past. And I needed to get real jazzed about it. I need to remember all the fun and cool things we were doing. And so in part of that, I started looking through and checking out some metrics, and specifically pull requests, looking at pull requests for all the nerves-related libraries and projects. And so the Nerves project obviously has the most. This is where you'll see a lot of the systems, the main Nerves tooling, the fun stuff like that. And this was kind of fun to see quite a big number of pull requests for the last year. Nerves Hub comes in as a nice second. Nerves networking with all the VintageNet libraries, connected to Ethernet Wi-Fi, that got some love too. And another fun, surprising wedge that came in here was Elixir circuits, with quite an increase of work and load done. And Nerves Live Book, another similar sliver. And this tiny last spot is Nerves Time. All right, it's looking good up there. It's cut off here, which is exactly what it sounds like, helping keep time on your embedded devices through several little libraries. It's pretty consistent, pretty consistently small. And for all you math nerds looking at these numbers trying to add it up, it's 1,132 pull requests towards the Nerve projects and related libraries in this year, which I think is pretty neat. Until you look at the breakdown, which is mostly Frank and all the rest not Frank. Again, for the math nerds, that's 58% done by Frank, and all the rest of it is all of us combined just not even keeping up. Over the years as well, pull requests to these libraries with kind of an interesting trend line. And I was getting all excited when I was seeing this number, so I was going years back, and then I started noticing a few years back had more and more, and I felt like, oh shoot, that's actually bad. We're doing less. And I sent this to Frank, and Frank had a completely different response, which I like better, which was, oh, this is great. This shows maturity in the project. When a lot of it is maintenance, a lot of it's in the weeds, a lot of it is seemingly sustaining. Why is this even on a list when we're talking about improvements and new and changes? And well, there's a few reasons. One is that small incremental changes are way better than larger ones. As you keep up with the changes of Linux, it's less work for you to keep it up with your systems. And also, you stay current with lots of bug and security fixes, and that's always muy bueno. So it's on the list, and a lot of work is actively done, again, all by Frank, to keep Linux up to date. So the big things this year was that Raspberry Pi got all the way up to Linux 6.1, and the BeagleBones got to Linux 6.6. Why is there a difference? Well, Raspbian has not quite gotten to 6.6, or at least at the time we was. And Frank told me his rule is he's not going to do more than Raspbian does, because it's interesting. It's hard. Let's just say that. It's not fun. With these updates, we get things like support for Raspberry Pi 5, more RISC-V, improved support, and a lot of various Wi-Fi modules. And some other notable changes or fun improvements we've gotten by this updates to Linux was this library we implemented called Deluxe, which is more of a high-level abstraction on the LED class driver, which can do lots of cool things. Like in 6.6, you can do grouping of LEDs, and you can control them as groups. This library also has a lot of built-in LED effects and prioritization, so that you can essentially make little programs with an order of of severity, and you can just set an LED's priority or notification. I've already forgotten the word, but you don't have to worry about the old state. As soon as this higher level priority state goes away, the old state immediately gets back enacting back to its blinking, fun nature. And another new library that has popped up is DTS Buddy. And if anybody has anyone dealt with device trees much here? You know the joys that are device trees. I see some resistant faces smiling, yes. This is a little library to help deal with device trees dynamically. Maybe you want to reload something at a runtime. Who knows why? You got crazy reasons. And it's there. It's very experimental, very interesting prospects coming out of it, and could definitely use some ideas, thoughts, and help. And that's all we'll talk about Linux. Everything else gets pretty in the weeds. However, it was recommended that this is, by Frank, the best website if you want to look at the differences of kernel versions and really nerd out into the nitty-gritty of what's going on in the Linux kernels. Okay, next up on my list of fun new changes that are new, build root. And you might have the same question, why are we talking about build root? Well, for the same reasons as Linux. Keeping up makes all of our lives better. So it becomes important. So this year, build root 2024-02 was brought in, and it, again, also helps support cameras with Raspberry Pi 5. Multi-tool chain support for new SoCs like the TI AM64X and AM67X. People nodding heads as well. It's like sad when you know the part numbers by memory and what that entails. And I'm sure this last one is definitely all of our favorites, OpenSSL 3. Yep, there's shared pain in this room. OTP now supports OpenSSL 3, so this is a nice new addition to build root that enables us. Speaking of tool chains, Nerves provides a lot of tool chains for consistent builds across platforms, and a big part of those is GCC, and we updated to 13.2, which, what was the previous version? Wasn't it like 11? No, it was 12. No, Frank keeps up to date. More security fixes, more bug fixes for C libraries, also better RISC-V support, and you edited my slide. Yeah, we were going to prepare for GCC 14.1, but apparently it was just released, so it's coming. Here it is. No res. One of our teammates also built this fancy new ASDF plugin, which is really nice and useful. The tool chains are called Nerves tool chains, but they're really very nice cross-compilation tool chains that can be used for many things. So utilizing this plugin, you can be outside of the mixed tooling, but still enjoy the benefits of the tooling you're going to use when you build firmware. We use this a lot with building Flutter in its own independent project, developing just for the Flutter part and not having to be within the Nerves or Mix app at the same time. All right, Erlanet. Does anybody know what Erlanet is? Is this a familiar term to anybody? Okay, 4, there we go. Well, if we were going to describe the boot up process in a nice little stacked graph and all the things that happen from start on the left in blue all the way to the end, Erlanet is this tiny little golden wedge there in the middle. And this is what, after the Linux kernel is loaded, ends up loading Erlang and the beams. I don't know if this was a typo to call it beams, but I liked it, so I kept it. And it does a lot of neat things that you probably never even have to think about, but are cool nonetheless. One of the additions to it was random number seed handling with seed RNG, which, according to Frank, turns out to be non-trivial. And why do you care about this update? Well, if you've ever had a device with weirdly inconsistent boot up, having random failed boots in between, but no apparent reason why, and you're just completely confused and dumbfounded in these troubleshooting sessions, it doesn't make sense, it's hard to reproduce, you might end up feeling the world's against you. The problem is usually because of this comment, which you'll see in every EarlInit configuration file of the nerve system, which says there's not enough entropy. It's not random enough on the boot up for the crypto loading and other things loading the beam that it just blocks. And the hardware watchdog might kick in, the whole thing might reboot, and it's totally random. In fact, when I first ran into this, I was really bashing my head on the wall, and I discovered that if I slammed a keyboard connected to it, I could get it to boot really consistently. And I tell Frank, and I was like, I don't get it, man. It's not working, but if I slam this keyboard, it works. He goes, oh, yeah, you're probably the random numbers, and you don't have enough processing to get that random number. And he was right. Apparently, slamming a keyboard produces enough entropy in the system for you. So seed RNG is another mechanism to help aid in situations like this by writing a seed file for the random number generator that can be used on the next boot. There are caveats and weird things that you could run into this, like if your file system can't mount and you can't write that seed file, then it doesn't really help, but it's yet another tool to help you get past that weird boot up issues. Also, in EarlInit added this year's writable rootfs support with overlay FS. And this isn't really used, but it's more of an enablement for experimentation. Nerve systems are traditionally read-only, and so adding some layer where you can be able to write to the rootfs and do a little bit of changes in there could, some people have use cases, maybe it's debatable, but at whatever rate it's in there, and you can use it. So speaking of weird boot up problems, the other thing you probably run into is actually NervesHeart causing that. So there's a lot of big improvements to NervesHeart. In fact, I want to coin a term, RDD, let's call it rage-driven development. And I think most of the next slides are Frank's adaptation of RDD, and watching these changes come in from him, you can just see the frustration that caused it. Like, let's increase more verbosity in the logging of NervesHeart. Or be able to turn it off. Sometimes you just don't want to be totally blocked from booting. And this one actually is a really cool addition. The application level handshake. This helps solve a case where the kernel comes up, NervesHeart comes up, but your application does not. And Alex is shaking his head. He knows.
Thank you.
When your application starts to tie in the Erlang heart system, your application has to call heart.setCallback. But if your application never calls that because it's crashed, the hardware watchdog and NervesHeart thinks everything's okay, and it never fails, but your application is never booting. So now you're just in a booted but not booted state. So by introducing this handshake requirement, NervesHeart is opinionated to say your application has to start and you have to tell me that it started, and then I'll start the whole watchdog process as normal. And if not, I'm rebooting you. You're doing your thing, you can revert, whatever. Oh yeah, this is another interesting edge case. Protection from hangs between requesting reboots and rebooting. That very small time frame from when you ask the device to reboot and it actually rebooting could sometimes have that freezing mentality. I don't know, you gotta talk to Frank, he's gonna have all the details. But that's helped and improved. And sometimes things don't fail until after it's boot up for a little bit. So now you have abilities to snooze the heart or the hardware watchdog so that you can get in We do a lot of remote troubleshooting, admittedly, and this helps the cases like that. We're seeing something in the field, we're not really reproducing. Get in and snooze it quick and start looking at the things. Some of my favorite changes of this year, however, are in Elixir circuits. And not technically branded nerves, but you can use Elixir circuits with anything that has the supported I2C, GPIO, whatever, even in Raspberry, but it's heavily used in nerves because built for hardware. And we're gonna totally geek out, and I don't even care. You guys can make fun of me, but some of these things are very nerdy, but very cool, like GPIO specs and labels. Nothing's more nerdy than getting excited about a label that you can control. The old way is to open a GPIO by its pin number that you see in some pinout, GPIO 0, 15, whatever. That's still supported. You can also give it a specification, the actual name of the chipset it's on and the pin of that chipset to open it up. And you can also use its defined label. So for those of you who are into device trees, you can now label all your GPIOs. You can call it what the manufacturer calls it. Like this one right here, you could call it My Cool GPIO. Doesn't even matter. You can label it and you can open it from that nice, pretty label. One-off reads and writes was an interesting improvement. Again, the old way was you would open this GPIO and then you would do something with it, like read it, and then you'd immediately close it. These are situations where you just want that quick value and that's it. You don't need to keep a reference around, you don't need to keep any memory around. You just want to know, maybe every 10 minutes or whatever, what that is. And now the one-off read writes can now handle that for you. Just do the quick read, the quick write, and be done with it, no extra handling. A nice, fun little optimization. And back to the rage-driven development is some built-in diagnostics. When I see these reports, I imagine the rage in Frank. What caused him to want to put this in there? But you can essentially connect two pins, and then you can test the inputs and outputs of each. You can verify if it's a hardware or software problem by running some quick tests, getting some data, maybe seeing some failures, maybe not. And so, lastly, there was pieces added to Elixir circuits last year, but technically not released until the beginning of this year, which is circuit backends. And I think we talked about this for a year or two. We always wanted it, but it was like the elusive, is it going to happen, is it not going to happen? Somebody needs to take the time. Well, last year was finally the time to do it. And what I mean about backends is you traditionally would have Elixir circuits that's mostly targeted for the specific processor. You have pins or you have I2C bus, you have things you know you're going to talk with. And you'd communicate over, everything would compile down to this NIF, and that NIF would get you the communication to the specific processor code and implementation. And this backend could then know how to tie in your Elixir circuits code through the processor to the actual pins and devices that you're connecting to. But say you attempted to run any of it on host for whatever reason, like test, the NIF would not work since it's very specific to the Linux and hardware support and setup. And in fact, if you try it, everything's probably going to blow up pretty miraculously. Or spectacularly, that's the word. So with this concept of these backends, you can now say, have this external device, and it can actually do GPIO over USB. And you know how to communicate over that USB. So you can swap out that portion, that backend, and use circuits like you normally would. None of this code swapping. Oh, I forgot the official term, but really trying to adapt your code to be protected against different hosts and targets. You can instead implement direct backends. Like even making some fake backend that does nothing except allow you to run your nice, beautiful test suite on host without having to change a whole bunch of code around the place. And that actually brings us to the next cool improvement, Circuits Simulator, or Circuit Sim for short. These are actually, I think that these are very cool. Gonna nerd out some more. There are several devices that are currently implemented, simulated, that can be dropped into many projects. And there's this whole system to be able to support more, and lots of examples here that you can even put in your own specific sensors, adapters, what have you, to be able to be simulated. And so if we're going to talk about the scenario, say you're using something like the SGP-30, this nice little gas sensor. You want to know how bad the air is you're breathing around you. You include the particular device as a child in your supervision tree, but any attempt to run something locally is definitely going to blow up with that because it expects an I2C bus that's going to do the things. So with Circuit Sims, you can drop this in as a dependency. You can then add in the emulated device and the configuration. I didn't realize till after that this all probably should have been scoped to a dev or test config, but it is what it is. And then once you have all that, now you can run your tests again. And I've even output that I can call the SGP-30 state and get some values. They're kind of nonsense. You might have to do work if you want to fake the values a bit more, but you can, because it's a nice, beautiful backend system. And you can even see that this I2C bus is the simulated circuits one. And so much better hardware abstraction, enable your unit tests on device without having to do a bunch of crazy workarounds. Let's go back to rage-driven development. We use logs a lot in our troubleshooting, for better or worse. And there was this desire to have better logs and easier to traverse through. And with that condition, Digit on our team just created this little TUI for Ring Logger called the Ring Logger Viewer. And it's got its own little command set. You can page through. You can see nice printed out lines. You can filter. And it gets used pretty heavily, I would say. So fun Ring Logger addition that you may or may not have seen through the last year. And since we're talking about logs and looking at things, let's move on to NervesHub. We have done some pretty fun improvements to NervesHub over this year. We use it pretty extensively at SmartRent. And we, like I mentioned before, we use a lot of logs, for better or worse. A lot of people like to use the console to get the details that they need for a device. And so naturally, when you're using the console with all your buds, you got to have a chat room for it. Because who wants to be switching in between Slack or Teams or whatever? So that's in place. And what Phoenix app is complete without its own chat room implementation? Also in the console, you're looking at logs, but sometimes you want the logs from the device. You don't want to just stare at it on the remote screens. So we have these baked in little file transfer support via this console, like uploading a file to the device. It might be questionable why you want to do this, but you can now. There's always got to be a case. By simply just dragging a file to the console window, it uploads it, puts it on a device. You have little configurations in NervesHub link of where you want these set upload files to go. And bada bing, bada boom. And this is incomplete unless you have downloading files from the device. So you can go to the opposite way. You can make this call to a NervesHub link helper function to then give it a path, and the file will get downloaded to your machine on the browser. Useful. There's a catch, though. This downloads to every single open console. There's probably a way that smarter people than us will figure out the JavaScript to get around that, but it's a feature, there you go. If you have 1 million tabs, which I'm sure most of us do, and 10 of those are the same console, you're getting it 10 times. And every person watching it with you is getting this file. But you know what? Deleting files is easy. There was also a lot of work for the device connect optimizations when the device first connects to NervesHub. And devices use WebSockets to make their connection to NervesHub. And if anybody has done anything with NervesSockets or WebSockets at scale, you know that there's this problem that always comes up. The thundering herd. The node goes down and every single socket that goes down might try to come back up at the same exact time. And this is really compounded with NervesHub because devices aggressively try to reconnect when the connection is lost. And the herd comes. And we knew that this was a problem. We knew that we were scaling lots and lots and lots of devices, and that would come at some point, but it seemed to hit us immediately at once. It's like the lights flipped, and we could no longer deploy to production. So we put our best minds on it. Eric got to work. He spent a lot of time optimizing every small piece we could think of that could be causing this failure due to this herd coming in and all these devices connecting on the WebSockets. Yet, no matter how confident we were in every change, this change was the one, this fixed it, it would still break. We even created a QA environment where we could spin up 60,000 fake device sockets to try to reproduce this herd, and yet it would work there, and we'd move on to production, and it would break with our bigger scale of devices. So in the end, we did figure it out, actually. And spoiler alert, it turned out to be because of this option. Does anybody know what this is? Yeah, the trauma is coming out in faces. This is it, this one option, this one line. Months of bashing our heads against the wall, optimizing whatever we could, and that was it. But let's not overshadow the immense effort that went into this. Let me explain a little bit of the problem, how we got there. SO linger is the time sockets should linger around in case I don't know what. I honestly, there's got to be a condition in which you want to set that, but I have not run into it. But they will linger around. Maybe they're waiting for it to reconnect and not have to reproduce all the state. But if it's there. So in NervesHub, you'd have devices connecting, and then we deploy, and a node goes down, or the device goes away or something like that. But these sockets still linger around. These processes still exist until they eventually time out of that linger option timeout and go away. But with a huge scale of devices, you now get lots connecting, some phantom sockets, more connecting. Maybe there's errors or failures. Also, when a device connects, there's a lot of database load to determine updates and all that stuff. And you can end up with a lot of these phantom sockets that all have memory, that all have usage, that all have cost, and totally just take down a server. Because it seemed to be an exponential scale of which devices could fail, reconnect, and now you could have lots and lots and lots of still existing sockets for the device. So after quite a bit of table flipping and utter moments of confusions, we started stepping back bit by bit, commit by commit, and we discovered that the real issue was actually Bandit, which is actually Thousand Island, which was actually this default option that Thousand Island put in 5 years ago. And it's honestly quite amazing that this was not more prevalent, that nobody else ran into this. They just went by. And so I guess all I'm trying to say is you're welcome. We took that one for the team and got it taken care of. And while I'm ragging on it, I do want to say that Matt Trudell was a huge help. He immediately stepped into this issue, helped listen to our problems, find the context, and then go, oh yeah, I think that this might be an option down in this obscure file. And sure enough, it totally was. So again, big thanks to him for his help. Everything he does with Bandit and Thousand Island. Since switching to that, it's been very nice and beneficial. And pro tip, if you ever want his immediate intense help, you just revert to Cowboy and he'll be right on it to get you right back. That was the kicker.
So did you set it to 0?
So yeah, it's gone.
I know it's even smaller or it's all.
Well, he removed the default from Thousand Island, and then we don't set it, and Erlang doesn't set a value. It's just 0. There's just no linger. So yeah, think about your options with WebSockets. But a lot of good stuff came out of this. The problem in the end turned out to be something simple, but we made a lot of really cool improvements because of the problem we thought we were having. And so now we don't have those problems because we implemented a lot of very efficient connection throttling at the socket level before we even spin up a lot of memory to do something with the connection, which was much more performant. And you can control this rate. You can fine-tune it to your needs, and it works really well. We also reduced a lot of the SSL binary data that was stored in memory across all these sockets and then replicated across a bunch of processes and really reduced an overall big footprint. And added some more efficient garbage collection around SSL connections closing, which every device was connecting over SSL. And this works really well. In fact, so well that Frank's told this story a few times, but we deployed this week at 12 p.m. Eastern, and nobody noticed. And we have a lot of devices. 6 figures, that's the number I can say, right? 6 figures of devices connected to NervesHub. And when Frank found out that we had already deployed in the middle of the day on a tool that a lot of the company uses, it was a mixed emotions. Part of the new improvements we've added to NervesHub are adding the support for shared secret authentication. Probably the number one complaint of anybody trying to do anything with NervesHub is, what the hell do I do with device certificates? How does it work? And it's complicated. So now here's an easier way. And let me break this down just a little bit. Shared secret authentication was, say you have this device that has a serial number, and you can, instead of using the mutual TLS certificate, you can encode this serial number into an HMAC with the shared secret that both the server and the device has, pre-provisioned, and it's this time-based salt that signs this identifier, sends it over to NervesHub, and if NervesHub can successfully decode it with the appropriate key based on the device site or the client ID, the token ID, words are hard, then it allows the connection. And this is really helpful. It serves as a simpler first-time experience. You can even do product-level JIT with it to create devices based on a product shared secret client ID. This is actually a really common pattern amongst several services, like I'm pretty sure Goliath does this. AWS has several flavors of these pre-shared keys. And we went through a lot of naming. Naming is hard. We called this a lot of things. What we ended on was shared secret authentication. And you can also do some, well, you will be able to do, it's currently in development, is doing some secrets assignment and rotation let's say you flag a device as compromised, you can prevent connection for those specific secrets, and you can also have this mechanism to rotate the keys on it without having to deploy new firmware. But all this said, if you're going to do any deployment at scale of NervesHub, that the mutual DLS certificates and those mechanisms are still going to be the preferred recommended route for the more securities. Another big thing we did was making it more deploy agnostic. And what do I mean by that? Well, basically removing the requirement to have to use AWS. It's a much more simplified, updated to latest runtime EXS practices, making it simpler to put in your own secrets and configs for it. Very much more simplified Docker file. We automatically create images. We publish those images to the GitHub registry, and you can then pull those images and put them wherever you want to put a Docker image. And the images are designed in such a way that you can run everything together from the single image, or you can reuse that image and run only start it up with only parts of the application. So say you want to scale 15 device nodes where devices connect to and 10 nodes for the web devices, and you keep them all separate, you can now use this unified source. And in fact, one of the community members has started a new public instance that he calls Nerves Cloud. And it is available for sign up if you want to do some experimentation connections to it, play with getting devices working. Good old Josh and his smiley face there. And he actually deployed this on Fly.io. So he was a big proponent in helping remove all of these hard requirements on AWS and making it easier to deploy to other services. Some of the things we have in the works for NervesHub are microcontroller support, specifically kind of experimenting and playing with Atom VM and its connections to NervesHub, and a whole new refresh of the UI, utilizing a lot of live view, making it a little bit fancier and easier to deal with. And then maybe one of the more requested features are what I've been calling connectors, ways that you can get devices communicating with NervesHub outside of WebSockets, like MQTT, HTTP polling, whatever new hot message delivery system you want to use. More separating that out so that we can plug in these connectors for your use case. So that was a lot of change log, and that's basically all I got for you. To end it though, we did create this survey to hear from the community about how they're using Nerves, how they want to use Nerves, how they might like to use NervesHub, and if you have a minute to spare, we'd love to hear your feedback, get some of the results here. We'll be collecting this until May 31st, and then distributing the results by June 30th. And that's all I got. Thanks for joining my talk. Sure. We got questions?
One second. Let's get you a mic.
I feel silly just standing right next to you.
I know.
What is JITP, JITP?
Just-in-time provisioning.
I've never heard of that. Cool. Easy question.
That might be an AWS term.
Yeah.
Yeah. Any other questions?
No? All right. Thanks, John.
Thank you. Where do you want?